So now I want to talk about potentially one of the most important concepts of this chapter, and that's really where we came up with the concept of geologic time. So when we were back in the Precambrian, remember understanding the designation between the Archean and the Proterozoic was a little bit arbitrary, right? We used geologic events. Well, now in the Phanerozoic, we're going to see that it's really easy. So remember, right, when we initially did the time scale, we didn't know any of this information down here. We did not know the ages of the Earth, right? We came up with the time scale long before we knew any of that information. What we did see, however, is this diagram. So over here we have the number of organisms, right, increasing as we go up. And as we plot out the fossils, something interesting appeared, right? We have these periods where you can see the rates go up and then they go down. And they go up and then they go down. And go up and down and up and down. Well, what we're actually seeing here, okay, are what we call extinctions and adaptations. So let's define those two words. Adaptive radiation, this is where we have lots of evolution. The number of species goes up. An extinction is where we have a dying off of animals. We're going to see that most of the time it's geology related. So the number of species lowers. So if we go back to this diagram, and let me clear these drawings here, we can see that we have these radiations and extinctions. So again, remember we didn't have any of this. So what we see is this pattern, right? And within that pattern, that's where we set the ages, right? The different time periods. So if you notice within the Cambrian, this time period begins with an adaptive radiation and ends with an extinction. The Ordovician is defined by beginning with a radiation and ending with an extinction. Silurian is defined by beginning with a radiation and ending with an extinction. The Devonian is defined by beginning with a radiation, ending with an extinction. That's actually twofold. Carboniferous, remember we have the Mississippian, starts with a radiation, ends with an extinction. Pennsylvanian, starts with a radiation, ends with an extinction. Permian, starts with a radiation, ends with an extinction. And of course you can see that same trend follows through for the Triassic, Jurassic, Cretaceous, and Cenozoic. So what's really important here is that you recognize, okay, that every time period begins with an adaptive radiation and ends with an extinction. By seeing this rate, right, these different patterns in the rock record, that's where we said, hey, let's make this one time period. Let's make this the next one, and the next one, and the next one. So hopefully you can see here in this diagram how we let the fossils, the evolutionary events, actually define geologic time. So that is why, if you notice, these time periods aren't evenly distributed, right? They don't last all 100,000 years or 100 million years, whatever have you. It's kind of random. Some are shorter than others, some are longer than others. And again, that's because, right, we let the fossil record dictate to us how we should break down geologic time. So that's an incredibly important concept for you to understand, because this explains how the geologic timescale was made.